My dad, he sold his like little guy on I kind of like my dad's old life. But it just,
I don't know how it's
doesn't look as.
You can high school like that. You can high school like that.
Okay, what I want to do first is finish up this partial fraction decomposition business, and then I want to. I remember I assigned section 7.5, and I thought I felt a little bit bad that I didn't do any problems from there, yet I assigned problems. So I'll be going over a few problems from there today. Yeah.
7.5 was homework that you emailed.
Emails you, yes. You don't have to turn them in; you just have to do them. At some point, I'll be putting some homework together on the web assign. Then you can do them there. But okay, let's look at the integral where I have 1 minus x plus 2x squared minus x cubed divided by x times x squared plus 1 to the 2. And in my previous examples, we didn't have any power on the quadratic factors. This time I have a quadratic factor with multiplicity 2. Okay. Once again, when I say multiplicity 2, I am speaking about the exponent 2 on the x squared plus 1. Now, what would be the partial fraction decomposition of this guy? Well, it is obviously proper fraction, right? Because what is the degree of the denominator? What's the degree of the denominator? 5, right? The degree of the denominator would be 5, so it is greater than the degree of the numerator. So let's write down the decomposition for the linear factor x. The factor x has multiplicity 1. So for that linear factor x, we are going to get the term a over x in the decomposition. For the irreducible quadratic factor x squared plus 1, because it has multiplicity 2, we are going to get two terms in the decomposition for that factor. And the two terms would be bx plus c over x squared plus 1 and dx plus e over x squared plus 1 squared. And then, of course, you have to solve for a, b, c, d, e. And when you solve for them, what you're going to get is a is 1, b is negative 1, c is negative 1, d is 1, and e is 0. Okay? And once you plug them in, you're going to get 1 over x plus minus x minus 1 over x squared plus 1 plus x over x squared plus 1 squared. And now we need to know how we can integrate them. Is everybody clear? You guys okay with that? Now, we know how to find the integral of 1 over x. Does everyone know how to find the integral of x, the third term? X over x squared plus 1 squared. Let me say you should know. Yeah, if you look at the denominator, x squared plus 1, if you take the derivative of x squared plus 1, that's 2x, which is lying in the numerator. So you should take u to be this, then you're going to get 1 over u squared, right? And you know how to find the integral of 1 over u squared. Or I should say you should know, you better know how to find the integral of 1 over u squared. So the third term, you should know how to find the integral by using substitution. U is x squared plus 1. Now, for the middle term, that's the one that is a little bit difficult, but what you have to do is what? Break it into two, like we did last time. We're going to break that integral, we're going to break the middle term into two terms. One would be negative x over x squared plus 1. The other one would be what? Negative 1 over x squared plus 1, right? So if you break it into two terms, you're going to get negative x over x squared plus 1, negative 1 over x squared plus 1. What is this? This is the derivative of inverse tangent. So this is the inverse tangent here. Once again, what do you do here? You take u to be the denominator. Then you're going to end up with 1 over u, right? Half du. This is going to end up with half ln of x squared plus 1. This thing here is going to end up with negative half x squared plus 1 in the denominator. Plus c. Is everybody okay with everything we did here? Did it make sense how the integrals are done? I'm not showing you the details there, but you should. I mean, you have done enough examples by now that these integrals should not be it should not be of any difficulty. Everybody's okay? All right. So that's the last example I wanted to do with partial fraction decomposition. I'll be doing more means maybe another one or two later, but yeah.
I really need to know how to find like A, B,
Yeah, you have to know how to find A, B, C, D. Again, I'm not going to give you. Remember, I did one example where I had I don't know. It seemed like I was about to finish the alphabet, but if you have something like this, I wouldn't be asking you to solve for A, B, C, D all the way up to N, right? But you should know how we did the examples. So everything we did in the examples, I think, are if you do enough practice, say you do those problems in the homework that I assign 2-3 times, you should be able to finish them, let's say, in 7 minutes. Is everybody okay? The first time you do it, it's probably going to take more than 7 minutes. But I'm saying once you have done them, you know exactly what to do. When you know what to do exactly, it takes less time. Okay, so you have to practice. You do have to practice, and when you did the homework problems, the extra credit homework problems, you must have done that, right? Again, if you have any questions on how to find A, B, C, D's, and so on, I'll be more than glad to speak with you in my office. Okay, but I will do at least one example, I promise, in the class. Okay. Okay. But these are, again, all the videos that I sent you before. They all have. They all include the part where you find A, B, C, D, and E. So the videos include those parts. Okay, some of the problems that I did here, they are also done in the video, and they show you how to find A, B, C, D. So I'm going to assume that you have or you will see those videos. Okay, so now what I want to do is go over a few problems from section 7.5. Section 7.5. And again, section 7.5 is basically it's a section where you are given a whole lot of integral problems. So far we learned many techniques of finding integrals, many formulas we learned, and this is the section where you're asked to apply it. Everything that you know about finding integrals. Okay, so these are a little bit. Some of them are a little bit harder or trickier than the other ones that you have seen so far. So let me see. Let me start with something here. Let's say I have to find the integral of sine inverse of x dx. How would you find that? Well, you basically have no choice but to try and see if integration by parts will help. So you should when you apply integration by parts, let's go ahead and take u to be sine inverse of x. Can you take dv to be sine inverse of x dx? Oh, that's a dumb choice, because you're trying to find the integral, right? You're trying to find the integral of sine inverse. When you take dv to be that, you have to find the integral, right? So that's that's going to be a bad choice. So this is dv would be dx. Okay, and then du would be what? 1 over and then v would be what? V would be x. So then I can say by integration by parts tells me what? You multiply u and v, and then you subtract the integral of v du, right? So uv would be what? X times sine inverse of x, and minus the integral of v du would be x divided by root of 1 minus x squared, right? You multiply v and du, and then I forgot to write when I wrote du, I should be putting a dx here. Okay, so that's what I get. And now how do I find the integral here? Yeah, you do it. You do a substitution where you take u to be 1 minus x squared, right? So if you take u to be, so this u is different from what we took u to be before. Okay, u is 1 minus x squared, and then you're going to get du to be negative 2x dx. So negative half du would be x dx. So if I use that, then what am I going to get? I'm going to get x sine inverse of x minus in my previous integral, x and dx will become negative half du, and I get 1 over root of u, and remember what I said, x dx is negative half du. Now I could say this is x sine inverse of x plus a half integral of 1 over root of u du. And do we know how to find the integral of 1 over root u? 1 over root u, so that's what? U to the negative half. U to the negative half by the power rule will be u to the negative half plus 1 divided by negative half plus 1, right? What is that? u to the half divided by half, which would be 2 radical of u. Yes. So we get x sine inverse x plus half times 2 radical u. That's the integral, and at the end I can add a c. But one more thing that I have to do here is I have to let's cancel out half and 2. What was u? U was 1 minus x squared, right? So let's put that back in. You can find the integral of tangent inverse and others in a very similar way. Everybody's okay? Any questions, anybody? Any questions at all? No? Here's another example. Let's say I have the integral of e to the x plus e to the x dx. This looks a little bit weird, but you have to make sure you understand exactly what this is saying. You have e to the power, the exponent is a sum, right? The exponent is a sum. So if you have something like, say, x to the 2 plus 3, right? Isn't that the same as x to the 2 times x to the 3? So here, this would be e to the x times e to the exponent is e to the x, right? Am I making sense? E to the x times e to the x. Is everybody okay? Now, what you have to realize is that if you look at the exponent here in red, what's the derivative of that? And that's a factor in the derivative of the exponent e to the x is a factor in the integrand. So that's why you should take a substitution where you're going to take u to be e to the x, and du will be e to the x dx. And so if you do that, notice that e to the x and dx together will become du, and then you get e to the u du, isn't it? Very simple, right? You get e to the u, and then the factor e to the x together with dx will become du. And now you just say, well, this is what? E to the u itself, and then what is that? I should add a c at the end. Okay? Is everybody okay with that? It looked at the beginning, when you look at the integrand, it looks a little bit bad, but it's actually not too bad, right? It's pretty, if you see it the right way, it's pretty easy to do. Any questions on that? Any questions at all? Any questions, anyone? Okay, so let me move on. Let's say I have the integral from 0 to 1 plus root of x to the 8 dx. There are two things you could do. You can multiply out 1 plus root x with itself 8 times. Okay, 8 times, and then you're going to get powers of x, and you can integrate by using the power rule. However, since most of us would not like it, let's try a substitution. So let's say, you look at 1 plus root x, you wish you had x to the 8. So let's take u to be 1 plus root x and see what happens. Well, what would be, if I have that, then what can I say about root x? What can you say about root x? Root x would be u minus 1, right? Am I right? And then what will x be? Square of that, right? In other words, then I am picking x to be u squared minus 2u. Well, I don't have to do that. Sorry. I don't have to do it now. Okay, so now what is dx? What is dx? Dx would be 2 times u minus 1 du, right? You take the derivative of u minus 1 squared. The derivative of u minus 1 squared is what? 2u minus 1 du. So we are going to now make the substitution here. This would be 1 plus root x is u to the 8. And then dx would be 2 times u minus 1 du. Limits of integration would be what? When x is 0, so remember x is going from 0 to 1. So what would be the limits of integration for u? When x is 0, u is 1. When x is 1, u is 2. Okay, now you could see what's going on here then. That 2 that I have, that can be taken outside, and you get u to the 8 u minus 1 du. And now you should multiply them out. U to the 9 minus u to the 8 du. And then, what is that equal to? U to the 10 over 10 minus u to the 9 over 9, 2 and 1. And you have to plug them in. You have to plug them in and see at the end what you get. Let me just say you're going to end up with 2 to the 12 plus 1 over 45. Okay, is everybody okay with that? Yeah.
Do you know when you want to do an x substitution rather than just like u?
Well, I mean, in this case, we took u to be 1 plus root x. Mm-hmm. You might be saying, how do I know I have to solve for x?
Yeah.
Well, yeah, when you take the derivative of u, right? When you take I didn't have to do it this way. When you take the derivative of u here, du would be 1 over 2 root x dx, right? Mm-hmm. So you have, if I have u is 1 plus root x, then you get du to be 1 over 2 root x dx. And then notice that from here I can say, because I have to be able to express dx entirely in terms of du, and in order to do that I have to say u minus 1 is root x. So I'm going to plug that in here, 2 times u minus 1. And then I multiply both sides by that to get this. If I don't do that, I cannot write everything in terms of u. Because this is already becoming u to the 8, and then you have dx, you have to write it in terms of du. Is everybody okay with that? All right, so another example. Let's say I have 3x squared minus 2 divided by x squared minus 2x plus 8 dx. Okay, so what should I do here? What is that? What should we do? Say it again? Yeah, the degrees are the same, right? So this is not a proper fraction, so I have to first divide out. Alright, so let's try to remember from our childhood memory how we did this. So x squared minus 2x plus 8. Okay, so what am I trying to match? I'm trying to match the coefficient of the leading term of the dividend. The dividend leading term is 3x squared, so in order to match that, I have to multiply the divisor with what? 3. So I get what? 3x squared minus what? Minus 6x plus 24. And then I have to subtract, and if I subtract, what am I getting? 6x minus 26. Is everybody okay with that? If you don't like the idea of subtracting, just change the signs of the bottom row. So change the sign of the bottom row here and then add. Okay? And then let's go back to the so then what can I say? Well, I could say that 3x squared minus 2 over x squared minus 2x plus 8, that integrand is the same as 3, that's the quotient plus the remainder divided by the divisor, x squared minus 2x plus 8. Now, everybody knows how to integrate 3. So now we concentrate on, so we rewrote our integrand 3 plus the proper fraction. Now I have to find out how I can integrate the proper fraction. And now the proper fraction, so let's concentrate on the proper fraction now. So the proper fraction is, what is it, 2x? No, sorry. 6x, right? 6x minus 26 divided by x squared minus 2x plus 8. Now, what's the first thing I should be doing? I should be factoring that out, right? So what do I get if I factor out 6x minus 26 Factor out the denominator, somebody? What do you get? Whoa. Why can't you factor it out? 8 is positive, and I think I made a mistake to begin with. This should be a negative 8. This should be a negative 8. And that changes something. Let's see. This should be a negative 8. And what's that's going to change is this guy would be a negative 24. This guy would then become 22 with a plus. I mean, there is nothing wrong. If I had a plus 8, that was fine. I could have done it, but what I meant to do though is this one. Okay, so this is 22. 6x plus 22. This would be a negative. Okay, so now we can factor it out, right? What am I going to get? X minus 4, x plus 2. Okay. Now I see why you guys were hesitant to say anything. Okay. So now what would be the partial fraction decomposition? I have two linear factors. Multiplicities are 1. Very good. So a over x minus 4 plus b over x plus 2. And then this would be 6x minus 26, which is equal to, so what I'm doing is that I'm multiplying both sides by x minus 4 times x plus 2. Yeah.
The left-hand side should be plus 22.
Oh, yes. Did I change that before? Yeah. Okay, so if I multiply both sides by x minus 4 and x plus 2, right? What am I going to get with a? And then plus b times? Is everybody okay with that? We multiplied both sides by x minus 4 and x plus 2. Right? Say it again. Oh, another 22, right? Thank you. Okay, now how do I find a and b? How do I find a and b? Well, in order to find the quick way of doing this for this problem that's going to work is that the both sides of this equation holds true for any value of x. Okay. This equation holds true for any value of x, so I can plug in any value of x I want. So let's plug in x. So plug in x equals to 4, and if you plug in x equals to 4 on both sides, what are you getting? On the right hand side, I am getting a times what? 6. And when I plug in 4 here, I'm getting 0. When I plug in 4 here, I get 6. When I plug in 4 here, what do I get? Huh? 46. And so that implies that a is 23 divided by 3. Okay? And similarly, you can plug in x equals to negative 2. If you plug in x equals to negative 2 on the left hand side, you're getting what? 10. On the right hand side, when you plug in negative 2, the a term vanishes, and negative 2 will give you negative 6b, and that tells you b is negative 5/3. Is everybody okay with that? Now, there was once I saw a guy who's, I'm not sure if he's a professor somewhere or shouldn't be a professor somewhere, but he teaches somewhere or something. And he was complaining why this quick way of doing this was not shown to him by his teacher. So he was complaining about it. But there might be a reason why sometimes you don't want to just show the quicker ways. The reason is, at the end of the day, you need to know a general way of solving problems so that you can solve any given problem by the same method. Am I making sense? The general way of doing things is always important to know, because so that you can handle any situation, right, with the general way. This way may not be working in some cases. Am I making sense? Or you can still maybe make this type of things work, but then there are other works that you have to do. So I'm going to redo this solving for A and B in a little bit differently. Okay. So once I got this line, once I got this line, instead of plugging in stuff, what I'm going to get, I'm going to say that, okay, on the left hand side I have 6x plus 22. On the right hand side I have, on the right hand side I'm basically going to multiply out everything, collect like terms. Is that making sense? What's the highest power of x you're going to get on the right hand side? The highest power of x you're going to get on the right hand side is what? X, right? X. So what's the coefficient of x? Can someone tell me what's the coefficient of x? I'm looking for coefficient of x. So how many ways can I get x from here? Ax. How many ways can I get x here? Bx. So I'm going to get a plus b. That's the coefficient of x. And then I'm going to get something constant, which would be what? 2 times a and minus 4b. 2 times a minus 4b, that's my constant term. Okay? And now, because the two sides are equal polynomials, the coefficients must match. So that tells you that a plus b would have to be what? A plus b would have to be 6, and 2a minus 4b would have to be 22. Right? Now, again, how would you solve them? Well, there are a couple of different ways you can solve them. But the way I'm going to do it is that I'm going to say, keep the first equation as it is. Multiply the first equation. Multiply the first equation by 4 and add it to the second equation. Am I clear? Multiply the first. So I'm trying to get rid of b. If I multiply the first equation by 4 and add it to the second equation, I'm going to get rid of b. So multiply the first equation by 4. So if I multiply 4, I get 4a plus 6a, right? So what is that? No, 4a plus 2a, right? Which is that? 6a. And then I'm going to get 4b plus minus 4b. That's going to cancel out. On the right hand side, I'm going to get 4 times 6, which is 24 plus 22. What is that? 46 again, right? So this is what I'm going to get if I do that. So I multiply the first equation by 4, add it to the second, and replace the second equation by this new equation. I kept the first as it is. And now what? Well, a is what? A is 23 over 3 as before. And then what am I going to do? Well, whatever A is, I'm going to plug that in here in the first equation. I'm going to plug in the value of A in the first equation and then find B, right? So what would be B? B would be 6 minus A, right? And whatever A is, you plug that in. So what is that? 6 minus 23 over 3, right? So what do you get? Minus 5/3. And you get A to be 23 over 3. Am I making sense? Did that make sense? The second way that I did, obviously, if you have more variables A, B, C, D, E, it gets more. You get more equations to handle and so on. Yeah.
In the second part of 6a equals 46, how did you get rid of the b?
I multiplied the first equation by 4, added to the second. So this would be 4a plus 2a, 4b plus minus 4b will cancel out, 4 times 6 plus 22. I multiply the first equation by 4, whatever you get, add it to the second equation. Now if you cannot do it in your head, just multiply this out by 4, write it out, add it to the second equation, and then whatever you get, that's what's coming here. Am I making sense? Okay, so so this is how you can find A and B. Now, again, I saw a teacher who was complaining about the teacher only showing this and not showing the other way. Okay. Obviously, the other way is quicker, but the problem is, this is this is the general way of doing things. That is, you can do it no matter what you have. Okay, you can handle all the problems this way. All these problems you can solve for A, B, C always in that way. But the quicker ways may not work at all situations. Am I making sense? So it's important to know the general way. So I don't know why he was complaining, but if he was a teacher, he should have known that you have to know always the general way. Okay? Everybody's okay with that? All right. So again, let's go back to what we started with. By this time we lost track of what we had, right? Let's go back. I was originally trying to integrate this. And then we said this is 3. We did long division, and we said this is 3. What was that? 6x plus 22 divided by x squared minus 2x minus 8. So we did long division and rewrote this way. And then what we are going to do is we're going to say, well, now I did partial fraction decomposition, and I got the second fraction to be what? What we said was that, well, let me write one more line here. Since this is the only problem that I can finish, I guess. This would be, we factor that out as x minus 4? X plus 2. And then we said, well, we did partial fraction decomposition. We said this is a over x minus 4 plus b over x plus 2. And then we also solved for a and b. A, we got what? 23 over 3 x minus 4. B, we got negative 5/3 over x plus 2. And then I can say this is integral of 3 dx plus 23 over 3 integral of 1 over x minus 4 dx minus 5/3 integral of 1 over x plus 2 dx. Okay, so now what's the integral of each one of them? Well, what do you get? 3x, right? 23 over 3. What's the integral of 1 over x minus 4? Very good. So this is that. This is this. Everybody okay? Alright, so I at least show you once how to find A and B, but this is a very simple case. I'm going to show you probably another one at some other time.